floating. So next lesson is integration by parts. You've probably done this before. Does the name sound familiar? No. Integration by parts. Did you done this before? You'd see first. Okay. Yeah. Okay. What's going on? Fix it later. Okay, I'm still waiting for it to open. So integration by parts is useful for when you have two things multiplied and you want to integrate. Like for example, if you want to integrate something like EX and sine X. So we know what EX becomes. It becomes EX. And we know what cos X becomes. It becomes sine X, for example. But we don't actually know how to do the two multiplied by each other. And this is not EX sine X. No. Okay.
Yeah, I remember. You integrate one and finish one.
Yeah. So we have a rule which I'll prove now. UV derivative integrate is UV minus integrate. Yeah. Well, I'll just write a bit differently. It's a bit more convenient. FG minus, U derivative V dx. So in other words, like you were saying, there's a derivative in it. So I'll prove this rule. I'll prove it first before we start, and then we'll use it. So the proof is very simple. All you do is you differentiate. So when you differentiate here, it cancels the integration, leaving you with UV derivative. And here we need the product rule. That's U derivative V plus UV derivative. And here the integration cancels the differentiation. That cancels that, and you're left with this. So it's true. So this is called the by parts formula. And when we have two functions multiplied like this, we can say it's equal to this. Now what you notice is all this does is changes one integration into another integration. And our hope is that this problem is easier to do than this problem. So this is kind of like the idea that we just change the form slightly. So this is the formula here. Maybe you want to write this down, and then we'll look at some examples of how to use the formula. Okay. Yep. Okay, here's our first example. X cos X dx. So what you do is you call this one U and this one V derivative. And I'd like to make a table. And here I write U derivative, V derivative. Got that? Now the U we know it's X, and the V derivative we know it's cos X. If I want to go from U to U derivative, I differentiate, so that would be 1. And from V derivative to V, I anti-differentiate, I integrate. So that will be sine x. Now I can use my rule. This equals u v minus u derivative v dx. Yeah? Now, is this easier to do than this? Much easier, because this is just sine x, which becomes minus cos x when you integrate. So the answer is just x sine x plus cos x plus c. Okay, so it's a first example. Maybe you should write this down. We'll make more difficult ones now. Did you do it like this before? Yeah. Did you make a table, or you did a table as well? Yeah.
Doing by first multiply, we put u and v derivative and u and v.
Made a cross.
Yeah.
Yeah. Yeah? Okay. Right, here's another one. Log x times x. Okay, this is one I want you to try. Going well?
Yeah.
Yep.
Yeah, I now also made them.
Same thing, yeah. Ready to see the answer? What answer did you get?
3x
Mm-hmm.
x cubed.
X cubed. Okay, let's have a look. So this is u and this is v derivative. So u is log x, u derivative is 1 over x, x squared, so v is 1/3 x cubed. So this is u b, this is minus x squared.
No, leave x.
Oh, sorry, I'm sorry. I know, yeah. It's 1 over x.
No,
Yeah. U times 1/3 x cubed. I think your cross might be different because maybe in school you wrote it like u derivative, v derivative, whereas I write it u derivative, v derivative. Maybe you wrote it like this because then it would make a cross. I think because I write it differently. 1/3 x cubed log x minus 1/3 x squared dx. So that's 1/3 x cubed log x minus 1/9 x cubed. Increase and divide. Yeah.
same idea.
Same idea. Okay, now do you know this is the same problem as this? But this one is easier to do and this one is hard to do. And it seems strange, but it matters who's first. And there's a little trick to help you remember which is the best way to have them. And I don't know if you did this in high school. LIATE. Do you know this? So you should always write logs first. So this is good, this is bad. Then you should write whatever's the inverse functions next, like sine inverse, cos inverse, tan inverse. The A stands for algebra, like x squared, x cubed. The T for trigonometry, sine, cos, tan. And E for E, exponential. So this one is good because the L is before the A.
What's the inverse?
Like sine inverse, cos inverse, tan inverse.
Yeah.
But this one is bad because the A is before the L. This one is good because the A is before the T, LIATE. So if you've got a problem like this, cos x dx, you should swap these at the start. It makes it easier to do.
We just made it by that. Who's easier to integrate? Because sine, tan inverse, or log.
Yeah, I suppose this is the reason. The easier function to integrate goes at, well, no, that's not really true. Because here, both of these are easy to integrate.
But x is easier.
Says who? Says you? I don't know. Anyways, it doesn't matter. I just remember it like this.
Tan.
Yeah, here it is here. Okay, I want to do 2 more examples. Try this one for me. We'll do 2 more. Integrate EX x squared dx. Got that? Finished.
Yeah.
So what was unusual about it?
I had to do it 2 times.
Yeah. So no problem.
Yeah.
Okay. Do you need me to do it, or do you think you got the right answer?
Yeah.
Yeah?
X squared EX minus 2x EX plus 2 EX plus t.
Let's check your answer. Call it out again?
X squared
Yep.
EX
Yep.
minus 2x EX plus 2 EX.
Like this?
Yeah.
How can I check if your answer is right? What's a quick way?
What I am
No, what I mean is how can I check if this is right, like in the exam?
x squared 2x 2 and EX. First EX without integration and the second EX.
No. Let's make life easy. If I differentiate this, it should make this.
Yeah.
Yeah? So let's check it this way. Derivative is 2x EX plus x squared EX minus 2EX plus 2x EX plus 2EX. 2x EX plus x squared EX minus 2EX minus 2x EX plus 2EX. Whew. Right, let's see. Gone. X squared EX. Good job, you are right. One more to do. Like the last one, but harder. Integrate EX sin X. Enjoy. See what happens.
This is gonna end.
Maybe not.
I don't think so.
But you can still get an answer. I wouldn't give you something that doesn't end. You can get an answer.
You can get it.
I promise. I'll show you the answer. Any luck?
I went back to the same redundant.
Kind of. Let me show you. Let me just save this picture. Right. Watch this. So I hope the first thing you did was to swap them.
Mm-hmm.
Yeah, good, okay. So we have u equals sine x, u derivative equals cos x, v derivative equals ex, and v equals ex. It will take a second. So this ex sine x dx equals u v minus u derivative like this.
Yeah.
You have the same thing. Good. Now you look at this and go, oh, I have to use the rule again. So integrate ex sine x dx equals sine x ex minus, and I'll just squeeze it in here, u equals cos x, so u derivative equals minus sine x. And v derivative are both ex, because it's e. So this now equals u, v, yeah, minus, and then the u derivative, which is minus sine x, ex dx. So now we have ex sine x dx equals sine x ex minus cos x ex minus ex sine x dx. Looks familiar?
Yeah, this one
So what do you do next? Maybe use by parts again? No, because then it will continue forever. Any ideas? Watch this magic. Bring this over to the left. Now you have two of them. Divide by 2 plus c. I have the answer. So the integration of ex sine x dx equals ex over 2 sine x minus cos x plus c. Interesting, yes?
Yes.
Yeah? Okay. So, before you go, I want to give you a question that maybe you can try before our next class. This one here, log x, we don't have a rule to integrate log x, but we can do a little trick here. We can say this equals log x times 1 dx. And we can call this part u and this part v derivative. And by using this trick, we can get an integration of log x. So we can anti-differentiate log x. I want you to try and do this later before the class, and then you can check your answer, because then the derivative should be log x. Yeah. So a mini homework for later today, if you can write this down, and then I'll see how you do later. Yep. Finished.
And yes.
No problem.